Okay, so hello, my name is Kacper Grzesiak. I work as head of sales here in Poland in the Polish office of ICEYE. ICEYE is a global leader in synthetic aperture radar imaging, and what we do is we manufacture, launch, and operate the satellites that you see here on the screen. Those are synthetic aperture radar satellites used for observation. In general, satellites are split into communication satellites and observation satellites. And then there's some more types for intel and very specific applications, but today we'll be focusing on the observation and specifically radar. And the reason radar is very useful is because it sees at night and through clouds. Here on the left, we see an image taken through our satellites. It is black and white, but it allows you to see through the clouds. The clouds practically don't interfere. Meanwhile, the beautiful, nice, colorful images that we are used to on a daily basis on Google Maps and other sources, unfortunately don't always work. Well, because there's clouds, and well, in certain latitudes, night can take up most of the day. For example, in Poland or even Finland, we have night for 16, 18 hours of the day in the middle of winter, which means for a better part of the day, we cannot use optical satellites. So in short, radar satellites are ugly, but they are most certainly much more functional and much more practical than and more reliable, most importantly, than optical images. So as I said, we see not just through clouds, we see through darkness, we see through smoke, we see through volcanic ash, which means even during natural catastrophes like when the Icelandic volcanoes erupt, or when you have any kind of weather events, such as storms or hurricanes, where there's a massive cloud coverage. We can see right through those clouds and, well, help direct help and the support services to the places where they need to be. Our founder, Rafał Modrzewski, he founded the company along with Pekka Laurila, who is our Finnish co-founder from Finland. Rafał went from Poland to Finland on the Erasmus program somewhere around 2012, started the project really at the university and then turned it into a company. Currently, we have launched 54 of our SAR satellites, which allows us essentially to complete this promise that you see on screen, which is that we can see every single square meter around the Earth within every hour we can get there. Since our satellites are on the low Earth orbit, they're close to the Earth, just like the International Space Station. They have to keep orbiting very fast, which means that they don't hover, they don't stand over the same place. That means that the more satellites you have, the more you can return to the same place. That's called revisit time. And this is how our constellation grew. So from 2012 when the project started until 2018, when the first satellite was launched, that's when Rafał was working on the company, perfecting use cases, and finally the first demonstrator was launched in 2018, as well as the first commercial satellite with the X2, which serves us until this day since 2018. This is the company's background, just for some of those who might be interested. Lots of funding, lots of constellation growing, more funding, more growing, and if you need to read this further, you can just pause the video later. Currently, I will skip through it. 800 people as of today. We have secured €500 million financing, actually more than that, because the Polish government actually just invested last week 10 million euros. Not huge globally, but for Poland, that's a big investment in space, private space company. We have approximately 500 people in Finland, about 130 in Poland. US around 50, UK around 20, Japan we have around 10, Spain 50, UAE around 20. So, and Greece is our newest office, which with something like 30 people there. So that's where we hire and that's where we work from. And sorry, as I mentioned, we are the largest SAR constellation, miniaturized SAR constellation in the world. So there is no other company in the world that has this number of satellites. And in fact, we are, as I believe, the largest in terms of revenue at this point from our competitors. These are the three things that we sell. So the most important are the satellite missions, and that those are the actual satellites themselves. We build them completely in-house out of commercial off-the-shelf components. They're more or less the size of a conventional chair, maybe. So 1 meter by 1 meter by 1 meter cube. These panels fold up into the cube. We attach that cube to the SpaceX Falcon rocket. The Falcon takes it up to orbit, and on orbit deploys the satellites at the same altitude. We then use those satellites in our own constellation, excuse me, to collect satellite data, images, the black and white images that you saw before. It's like the same one here. We just sometimes apply different color masks to make them look more interesting for marketing purposes. But at the end of the day, it's all the same data. It's radar data, radar images of the Earth that we sell to our clients directly. So here we sell satellites, here we sell just the data itself. Solutions is kind of data, but improved. So we don't sell the images anymore. We sell actual data from the images because we realize that certain clients, such as insurers, don't care much for images or any kind of image files at all. They just care about Excel files or maybe some specific data that needs to be plugged into their systems. That's when we apply solutions teams capabilities to convert some data or derive data from here and convert it to nice maps, which I will show later. That's actually visible here on the right. So we can produce a water depth map when there's a flood. This dark water here, that means that there's, that's let's say the river bed. Here where it's lighter, that means the water flooded, but it's only, half a meter flooding. And then where it's very, very light, where it's bright, that means, maybe even less flooding than before. And then we overlay that over the map of the insured buildings. For example, the red ones got flooded completely, the yellow ones got flooded slightly, the gray ones are completely unflooded. So insurers can quickly make decisions where to send help and also obviously how large their payouts will be very soon. That's the satellite, how it looks when it's still being manufactured. This is obviously a render, but very close to the real thing. So data. So as I understand today's Fireside chat or seminar is about the capabilities that ICEYE could offer to companies. So
Yeah.
so pretty much I will dive into, because I realize we don't have that many industries represented currently in the audience, but in case someone's watching online, I will go through a bunch. So honestly, ICEYE is very, very versatile and willing to work with any industry, really, unless it's obviously for the greater bad of humanity. In general, we try to work with companies that work towards the good of humanity. But improvements in energy, improvements in maritime, obviously mining, but only mining that isn't underground, mining that is overground, so such as open pit mines, because you can see inside those. The radar pulse does not, permeate the ground. It bounces off the ground, so we can't see underwater. We can't see underground. Utilities, I actually have a use case about that later. I mean, energy, water, pipes, all of monitoring any of such infrastructure is possible from the orbit. But as I said before, insurance and also that therefore financial, because insurance is mostly finance, these two are completely available. Security is a huge one that we started off several years ago, and it was just protecting large sites. Now, of course, we're talking security of countries and continents because we entered the defense sector when the Ukraine war started, and but security obviously still applies in the civilian commercial sector still. A very, I think, good example to just paint a picture of how the satellite data can be useful. We can monitor pipelines, their structural integrity, whether there's any leakages from them. Certain things are visible on radar that are not visible on optical. I mean, the reverse is also true. We cannot see colors or some other aspects of the spectrum, the visible spectrum. So obviously that's they're complementary technologies and best used together with data fusion. But all in all, there are many examples of images that can sort of help you understand just how much we can see. And again, this is visible at any point in time. So if you're, let's say, a port authority trying to manage some sort of traffic going in and out, and you need one image every single hour or every single, half a day, it's practically guaranteed that you're going to receive that image no matter the clouds, the weather, anything. So that's very valuable because you can just plug that into your model of operations and you can safely assume that that's going to be a reliable source of data, and it's not dependent on, the wind or any as I mean, such as, for example, our competitors are drones. Drones are used for, patrolling, for monitoring, security, whether there's any leakages, sure. But if you have a ship leaving out on the ocean, it's very hard to monitor things on the ocean or on the sea when obviously there's wind. I mean, in general, it's hard to get a drone up over the ocean because it's very far and battery life doesn't last unless it's one of those high altitude pseudo satellite systems like high altitude drones, but your conventional drones will get swept away also by strong winds and when there's a storm. So obviously for us those things are irrelevant. Uh, a case just so that you can see how we observe power lines. So our best resolution image is 25 centimeters. I realize this is very grainy on my side, so it must be even worse on your side. So this is an image that was zoomed in very, very, very far. But the point here is that you can actually see individual power lines on this image. Now, a standard power line will be somewhere between 15 millimeters, excuse me, maybe 20 millimeters. At worst, at thickest, excuse me, it'll be somewhere like 30 millimeters, so 3 centimeters thickness. So despite having a resolution of 25 centimeters per pixel, if there's something that is very, reflective, such as a metal wire, but it only has, 3 centimeters thickness, it will still reflect, and obviously that one pixel will shine up. And if there's enough space between them, we can resolve individual cables, such as here. So it's and these are the actual cables, these white spots. We obviously only see those where the radar pulse reflects directly at us. Here, where the cable goes up, because it works as a parabola, these reflect the radar pulse in a different direction. So the radar wave effectively works more like sound. It sort of bounces off different places, and we can see certain things that you cannot see with light. For example, under tree coronae. In this case, you cannot see that because we're using a different mode. In this case, we're just trying to establish whether there's some sort of tree growth growing onto the power transmission corridor through the forest, and whether you need to send in a helicopter or not. So normally you would need people walking here or sending a drone or a car to drive, hundreds of kilometers to see if these forests are growing in. In this case, we can step in. And I mean, literally, ICEYE can be used for any application you can imagine. These are just some examples that we came up with. Anywhere where you have a large terrain, anything that is remote, anything that is large in terms of its space, general area, those are the places where ICEYE obviously outperforms the competing alternatives on the market, such as drones or well, people or other machines. This is just more power line examples, just to show you that we can still see the power lines. This is for radar. This is absolutely unprecedented that you can see actual cables. I realize that for optical imagery, this is not impressive, but again, radar is far newer and far less developed technology, in which we simply need to catch up behind the optical with the resolution. But we're almost getting there. Now, when it comes down to the actual use cases in general, more than just your creativity, I would use a certain formula, which after 5 years of working here, I've sort of realized, because our images are actually some of the most expensive on the market if you're tasking new images. The archive is also expensive, but not that expensive. When it comes down to the actual images, we start somewhere around 1,500, so 1,500 euros per image, and that's this largest image here, the one that's 100 by 100 kilometers. That's the lowest resolution with the 15 meters. And we continue through the strip. This one costs somewhere around 2,000 euros. It's 3 meters resolution. It's 50 by 30 kilometers, so smaller, but greater resolution, 5 times greater resolution. And at 3 meters, you can already resolve, 1 pixel is a car. So these are mostly used for huge areas like farms, for trying to see ships on what detect ships. So we're not trying to find out what ship this is. We're not trying to see what's happening there. We just want to know, count the ships. We want to see if they exist, if the fields are, sown or if the fields are even there, if there's a forest. These are just used for searching. If we want to know further information, we use different modes. It's the same satellites, but they switch the modes. So in this case, we switch to spot or dwell, which have a 1 meter resolution or half a meter resolution. We have now introduced spot precise and dwell precise, which have 25 centimeters resolution. And we have spot extended area, which is a 1 meter, but still wider. And I can add that we can also increase the number of these strips to at least 16, and here at least 8 in one go. So you're not just limited to one single frame. This is just how we bill by the frame. And so if this one, the largest, most lowest resolution costs around 1,500 euros. These end up costing somewhere around 2,000, 3,000, and 4,000 euros per, with as the resolution increases, that's how we bill more. That's how we charge more. And so what I'm trying to say here is that essentially, with such costs, you need to really be able to essentially figure out your ROI for this technology. Like, does it make sense for you to use this technology to order these images? Because quite frankly, if you're going to order something so expensive, you need to actually have, derive value sufficient enough to offset those costs. And the only places, this is the formula really, the only places where such, 5,000 euros per one single image. The only place where such value can be, obtained by using these images is honestly when you're protecting either super expensive infrastructure or, vehicles or, sites such as ports or oil refineries where everything costs in the millions, like one single pipe can cost like $50 million just because it's made of some very expensive material. Well, then of course it makes sense to spend a measly 5,000 euros to protect this highly important, sometimes strategically important to the nation infrastructure. However, there are also some other situations, and that's when you have suspicious activity like the shadow fleet of Russia, where they are currently using ships to dock to other ships in the middle of the sea. They transfer over the oil from Russia to, let's say, a Portuguese ship. Sorry to any Portuguese, but just any ship. And that ship travels to, I don't know, Singapore to sell the oil, pretending it's not Russian. So that's like a mid-sea oil ship-to-ship transfer, and we are able to detect these situations and obviously provide valuable what do you call it, evidence to, let's say, the criminal court. But that's not really useful to for commercial applications. Obviously, if you have a commercial fleet of vessels, you can just monitor them, where they're going, where they're heading, and whether they are safe and secure. So first of all, expensive infrastructure. The other aspect is, of course, human life, and that's even easier to sell to when it comes down to clients. If clients are trying to protect human life, that's even easier than infrastructure because, well, for the most part, as I think we all agree, that life is pretty much priceless, and so it's hard to put a price on life, and therefore, if with one image you can save even one life, then that's a pretty good ROI from a perspective of business. So, really, if you have hundreds of employees, if you have any situation where people are in danger, where maybe your machinery could endanger other large amounts of people or any amount of people, really, that is another situation. And if our imagery can solve that problem for you, easy. Otherwise, if we are trying to see if, the how many trees are planted in the center of Warsaw, or if we're trying to see if there's maybe satellite dishes being mounted on roofs or things like that. I mean, I spent 5 years, unfortunately, trying and telling people that their use cases are simply not enough value, and of course, only later they realized, this is just not the place where value can be derived. But sometimes there's rare situations where it works. Obviously, the company ICEYE started because we were starting to monitor sea ice, and another good use case is when we have oil spills or situations of any kind of endangerment of the environment. So obviously infrastructure, people, and the environment, those are the things that we really care for as a civilization. So we need to, obviously take good care, and in that case, money ends up being not so important. Our actual first missions, so if you may remember, there were missions, data, and solutions. Our first missions customer was actually the Air Force of Brazil. and they were the ones who purchased new satellites to monitor the illegal activity, illegal logging in the Amazon rainforest. But it's not just monitoring; it's actually enforcing it. So that's why it's the Air Force. They didn't buy it for military purposes, but they themselves fly the helicopters and catch the bad guys who are there cutting the rainforest down, and obviously they don't just observe the rainforest disappearing; they try to catch them and remove them. So again, these are the modes. This is an example of what you saw here. So we have dwell. Spot is just a single image, but dwell is essentially an image which lasts for 30 seconds. And so we combine them together, reduce the noise, we make it far less pixelated, it looks fantastic. But someone realized that, oh, actually, if you take those 30-second images, 30-second stack of images, and just make a GIF out of it, we actually have SAR video. And so that's how we made SAR video. Not sure what the frame rate is on your side, but this is regardless of
It's
the
okay,
frame
we
rate.
can see it.
You can see that it's moving, which means that's all
Yeah,
you
yeah.
need to know. Because if you know the frame rate of the video, and if you can see how much it has traveled in terms of distance, you can then derive its trajectory and speed, which can be very important. Exactly, if you're trying to track your fleet, or if you're trying to track someone else's fleet, Russians maybe, or not, and of course predict where to try to catch the ship later. And it just doesn't have to be ships; it can be cars, it can be trains, it can be anything. And then solutions. I'm not going to speak much about this because obviously solutions are mostly for the solutions team, which I'm not part of. But just to tell
Mhm.
you, they are mostly focused on natural catastrophes and floods. That's one of them. Forest fires, winds, very strong winds, tsunami, earthquakes, volcanic
Earthquakes.
activity, structural integrity of bridges and dams, illegal logging, and oil spills on land and on sea. And we provide a product so this is actually just it's not just images, it's not just additional data, it's actual product. So we provide a before product, a during product, and an after product for these three because that's the ones that are live. And then these are in R&D in the sense that we provide customers if they really need help, but it's not so commercialized just yet. Here we have a pre-flood, a during flood, and an after flood product, which allows each of which has a different property. Then obviously that's based on multi-source analysis, and the data comes from many different places that we have built up as sources over the last 5 years. Yes, we care a lot about resolving global challenges. And this is a nice example, I think, of nice example. Excuse me, a visually striking example of where our solutions team capabilities actually met our military overlap. They overlap with our military clients. So in this case, the Ukrainian dam was blown up by the Russians and the water spilled downstream. So we were able not only to map the damage so that later on we can also help Ukraine assess, how much the Russians damaged their country, but also in the meantime we were able to quickly send help. Well, we didn't send the help, but we sent the information to the Ukrainians so they could quickly themselves figure out how to help the people who are in the affected areas who actually live there because most of this was just forest or fields, but there were people living here and here, so who were underwater, and so that was a good example. But it's not just Ukraine. Obviously, we monitor over 180 floods per year, and one of which was in Poland recently. We had a flood in southwestern Poland
Sure.
last year. It was the Boris low, which is actually the same Genovese low that we are having right now, which is making our summer really cold here at least. And but back then it actually ended up with massive floods, and so we mapped. These are just some snapshots. We mapped the entire Poland, the entire country, and we have lots of press because of that. This is just some examples of actual images, just so you can figure out maybe some familiar places. Not sure who here is from where, but the one thing that you'll notice on SAR images is that mountains and anything that is tall, so mountains and tall buildings end up getting very stretched. They seem very sort of pronounced in terms of their height. That's just the nature of the imaging mode itself. The fact that we send the radar pulse and that radar pulse hits the top tips of the mountains first and then slowly hits the bottom means that it sort of stretches the toll just because there's this micro difference in terms of very short difference in terms of time between when it strikes the top and the bottom. The same thing you'll see with buildings. So these buildings are not that tall in Dubai, even though obviously most buildings in Dubai are tall. but they um, but they in general everything else looks pretty much similar to how it should look. It just looks black and white, kind of matrix like, a little bit transparent at times. That's what I mentioned earlier, that the radar pulse sometimes acts more like a sound wave than a light wave, because it'll hit behind the building, bounce back, and we will actually see what's behind the building, but only if the right conditions exist for the radar pulse to be bounced back towards us. We don't actually see through materials. We don't see through water. Um, we can't even see through glass, actually, surprisingly. Glass will bounce off the radar pulse, even though we can see as humans through glass. And then, like I said before, some of our images are used just for detection, monitoring, borders, counting the vessels that are surrounding you. Obviously, this is the part that sort of touches very gently on our military involvement, but I obviously try to not include that in our commercial presentations, because defense sector is an entirely different realm, if you want. That's the dwell mode that I mentioned before. So here we have an example of a completely forest covered graveyard. And if you were to look at this through a optical image, you would just see a green forest here. You'd see nothing here. But because our dwell mode sort of gets sent throughout 30 seconds, and since the satellite is traveling at 7 kilometers per second, it starts at a certain angle, and when it's done, it's already at a different angle, which means if you combine the different angles, you can actually figure out what's underneath the forest leaves. And so that's why we can see these individual gravestones, which are these white points here and here. No one cares about graves as much, probably, to pay for this imagery, but in the context of Ukraine, this applies a lot because they have lots of equipment hidden in forests, and that's how they managed to destroy so far over 8,000 units of Russian military equipment using just ICEYE imagery since the beginning of the war. So we're talking billions of dollars worth of damage, just thanks to some geek at our company who decided that dwell should be a mode. And I guess if you want to know a little bit about the military aspect here, Satim is our strategic partner from Krakow. OREC is essentially it's object recognition, and what they do, they first they recognize whether a plane is a plane. So, like you may have seen here, this is our image. This is the way our image is delivered. This is just for marketing purposes. This zoom here. But in short, you would simply see this. With the naked eye, you can see essentially that these are some sort of a plane. Maybe if you zoomed, you'd see that there's two engines or four engines, so you can start guessing what kind of a aircraft it is. But in short, it's very hard for the naked eye to still realize, because of the graininess, the pixelation, the type of imaging, what aircraft are. There are and all kinds of different units here. There's cars, etc. So what these guys did, they essentially ended up. And when I say these guys, excuse me, the CTO is actually the wife of the CEO, the Stasha. So absolutely technology built by women in this case. And the applications here are amazing, because like any AI tool right now, they ended up running out of data to scan. Like, we gave them a couple hundred images to try to detect and teach their machine learning algorithms what a ship looks like, what a tank looks like. And so what they decided to do, like most AI companies, they just created their own individual synthetic signature generator. So signatures are just these things. Literally, that is a signature of a ship. And since they ran out of images to try to put such signatures in squares to teach the algorithm, they generated them on their own using this very, very complex, very, very successful engine that they created using 3D models like they created here. And that allows them to then run our images through their detection algorithms. And in a matter of 20, 30 seconds, this is what happens. The ships get first, they get recognized. So at first they get detected. So there's detection, classification, and identification. They first get detected, and that's the sort of the yellow bounding box around each vessel. Then they get classified. That's the next level down. We can see that this is a barge, that this is some sort of a class, some Wuyan class ship, or this is an aircraft carrier. And then After that, some vessels, because they're so, close to the actual sorry, because they can see so well what's on top of the actual deck, they are able to even identify which ships they are specifically because, well, they know that this warship has been in these waters for the last, 6 months, and there's no other warship like it. It's got to be this one. Look, it's got this matches this specific feature, etc. And that way they can take out hours or hundreds of hours or thousands of hours of analysts time uh, finding items, and I mean that can also work both ways, taking away jobs from humans. Fine. Agreed, except in this case no one could possibly know just what the hell this is. And here, and I mean, here, these look like nothing because the image is so grainy, because maybe it's an old mode, or I mean, they don't just use ICEYE imagery, they also use our competition, and that might not be so good. Uh, but the point is here that humans might not be able to detect something at all, or they'd have a 30% success rate. Here they have a 90 F1 score of 95% success rate in detection of vessels. I don't know, greater than 20 meters or 30 meters. There's got to be some, and obviously they moved on to onto aircraft. After vessels were first because they're large. The larger things are, the easier they are to detect and classify. Airplanes, jet planes are smaller, cars are smaller. But they obviously also moved on to other areas and expanded onto even weapon systems. So that's just so you know that AI can be used very reliably for the purposes of analyzing the imagery. ICEYE just doesn't do that anymore because simply we are uh, because we are so busy building the actual satellites that we just don't really have time to anymore to analyze the images. Those are entire companies built around each separate analytical vertical. These guys analyze cars. This team, finds out forests. These people there analyze oil spills, and they're all separate companies because that's just how much specialization is required to get that right. So I think that's as much talking as I can do about this topic
A
before
lot of
everyone
the,
sleep.
yeah,
Any Q&A, very welcome. Let me know any thoughts, comments.
yeah, yes. As you said, a lot of talking. Thank you very much. Like it was a lot of slides, a lot of valuable information, and yes, and as you said, uh, if there are more questions, we can ask now. Kacper is here for us to answer.
I have no
Okay, what?
questions.
Oh
Just
yeah, yeah.
wanted to
Go
thank
ahead.
you, and I need to leave. So thank you so much for the information. It was super interesting, and see you soon.
Of course. Pleasure to meet
Thank you
you.
very much.
The
Bye bye.
same. Bye.
Bye.
Okay, then so I would like to ask one question about the legal aspect of taking those photos. I don't know if you are the person who knows more about this, but I wonder because you said that you can take photos all around the world, basically wherever you want. But can you take photos all around the world?
I think the simple
Mm,
answer there is that, and this is also an advantage of satellites over drones, in that drones have to actually enter airspace. So
yeah.
if we want to fly a drone from Poland to, over Ukraine to Russia, we will need to fly through air because by definition drones, use engines that rely on air
Mhm,
and wings for uplift for the uplifting force, etc. Satellites are above airspace. So they're in actual space, and there's no
mhm,
division of space into airspace as airspace conventionally would be. So the fact that we orbit around and our satellite is over Russia, that's just the nature of orbiting, Objects, the moon also orbits the Earth and sometimes happens to be over Russia. So if the Russians suddenly hated the moon, they have nothing to do about that. Same with our satellites.
mhm,
Now, when it comes down to the actual image acquisition, as far as I understand, there's just no way to really regulate that, and or at least we are still in the moment where that is unregulated because the law hasn't caught up in a way that in any meaningful way. So I can't answer fully. I'm sure there's like an actual follow-up to what I said about the airspace, But there is also a simple way to counteract if you don't want to have your images taken, at least by radar satellites, and that's you can do radar jamming. So you can really send a super strong pulse into the sky, or in a certain, let's say, angled part of the sky, and any
Mhm.
satellite that will fly through there, and if they're in that part of the sky pointing their radar at you trying to take images, their radar images will just be like, like the old TVs from the 90s, gray, sand, because you're gonna overpower their systems, and it's like so that's what radar jamming is, and Russians use that a lot in their key strategic
Okay.
sites. But I haven't ever heard. I mean, that's really a question for ChatGPT, actually.
But you think it's reliable source? Like
I'm
to
sorry?
ask ChatGPT? You think it is the reliable source? Like to ask ChatGPT if
It's worth asking and then evaluating based on the answer if it seems credible or not. Seems legit, seems not legit.
okay. But there's technology that might like influence your photos that you can be like blocked, as you said, like about this jamming.
Yep.
For
Which
example, in
cannot be
Russia.
done with optical, actually. That's actually an advantage of optical because it's very, I mean, maybe there's a way to jam optical, but it's definitely harder than radar. I guess with laser, yeah, but then you have to actually get exactly that satellite in the direct sensor, which is much harder to do. Um, ChatGPT claims that Earth observation from orbit is legal under international law, especially under the 1967 Outer Space Treaty, which recognizes space as the province of all mankind. Right. So what I said about the airspace and allows
But do you have
people to
ChatGPT Pro or normal version?
yeah.
Okay. I
Yeah.
personally I use Gemini.
You
And
input.
then,
Right.
okay.
Yeah.
And
There's
also,
no way to
yeah.
legally block orbital observation, even for military and strategic concerns.
Okay, but we are talking about blocking. So like before
Mhm.
taking a photo, okay.
Mhm.
But now if we talk after taking the photo, like for example, to take a photo of Russia, like the example you have used a lot today. So maybe after the photo, they can see that you take photo of, for example, the base or something, and they can sue you for this.
Well, like I said, according to what I just read, it's
Mm.
not, it's really difficult. First of all, it's very difficult to regulate. I mean, how, will you, say, I mean, honestly, first of all, I'm not a lawyer. So we're entering
Yeah,
territory
yeah, I
where I'm
understand.
not an
Yeah.
expert. Um, hmm, um, I mean, apparently it's legal under international law
Okay. So
based on the
okay.
Outer Space
Yes.
Treaty, right? So it's not legal under international law. So countries can take images of military bases. Uh, Individuals or companies cannot. It gets very tricky.
Yeah,
Yeah.
I guess like uh,
Yeah,
I
this
think
is
law
this is
is very tricky.
maybe this could be find a expert in space law and invite them because this could be a potential
Yeah.
idea for your next talk.
Yeah. So yeah, I think we can go back to sales. So I was wondering because throughout your talk, you were talking about, for example, taking photos of how many windows there are in Warsaw or something like this.
Mhm.
So I was wondering what was the most funny situation that client asked you to potentially take photos space.
Hmm. Hmm.
Like because, for example, I really like football, so I can imagine that someone would like to take photos of all
Yeah.
the football
Yeah.
pitches
Yeah.
in Poland.
Yeah. Well, I think, I mean, this is not going to be very funny to your standard average person, but I mean,
Let's
there
see.
were requests for people because people don't really understand. That's why, today I tried to explain
Yeah.
why the technology is actually where the technology is useful and where it's not. And for example, underground, we can't take images, but still people,
Yeah.
give us calls or write emails requesting that we take images of underground mines. Just last week, I got a call from someone asking me if we could find, water, uh, sources with our technology. Um, Funny. I don't know. I can tell you a funny use case that works, and that's we take photos of in Minnesota. There's 13,000 farms of sugar beetroot, and that's for the American Crystal Sugar Company. And we monitor 1 billion beetroots being harvested in under 6 weeks just to make sugar. I find that pretty funny that, we have military technology. Here we're
Mm,
observing Russians, and here we're just
mm,
collecting beetroots. And then better yet, we observe like once we put the beetroots in like this giant mountain. If the
yeah.
mountain collapses by 2 inches, that means the set middle beetroots are rotting. So then you need to move the beetroots. So, multiple applications. Sometimes I work with the military, sometimes I work with beetroot.
Okay.
And that's
But
actually a good use case for companies. I mean, if you have any kind of resources or of any kind really, and you need to observe, do volumetric analysis of whether your resources are increasing, decreasing, if there's theft, if there's any kind of issue like that, obviously this technology works for that, no matter how funny.
Okay. So you are based in Warsaw, like
Yes,
every day you work in Warsaw, but you
yes.
cooperate with companies all over the world.
Correct. Well, we have,
Mm,
I mean, when I was joining 5 years ago,
Yeah,
obviously I was able to work with anyone in the world. Today we have
yeah,
far more, let's say, organized team structure. So if we have clients
yeah,
from, for example, today we had a client from somewhere in the south of Europe. Then if there's a representative for south of Europe, I will most likely pass that over to them.
yeah.
Uh,
So yeah,
if it's like a strategic client or important clients. If it's a small job or a couple of small images, of course we will all handle it. But if it's like a strategic client, it just makes sense for someone from that region to handle the account because obviously they'll know the nuances better. They can understand they can speak the language most importantly. So
yeah. And also during your presentation, as a man, which like for me, colors are very, very difficult to understand. But
yeah.
I wanted to ask why different modes have different colors. Maybe do you know how this is influenced? Because some of them are more green, some of them are blue, other are like
Yeah,
gray.
so what I tried to explain earlier, let me just find this. Sorry, 1 second.
Or maybe I didn't understand enough because as I said, like colors are pretty hard
I think
to
this one will
understand.
show you. This one will show you
Mhm.
perfectly what we do. So if you look here, this is just an example of
Yeah,
two vessels in the Strait of Gibraltar,
yes,
and
that's
the,
green.
the the image in the background is gray because that's a raw
Yeah,
image. And then what we
yeah,
do, we just took that image, zoomed up on it. Oh, sorry,
yeah.
and we
Yeah.
applied a green color over it just so that it looks more appealing for a presentation because this looks better than the black and white. But
Oh,
that's just a stylistic choice. It's just applying a filter. We apply a green filter so that
okay.
it looks nice for marketing. Our images are black and white.
Okay. So you apply colors
Yes.
for different situation.
Yes,
So
yes, yes.
okay, so i- like are there any like conclusions like which sectors prefer like which colors? Is it like some kind related or how is it
No, for
chosen?
the most part, we just use the green because that's our stylistic choice of our marketing color scheme. So we
Okay.
just we just use green. I mean, we don't color them red. We don't color them yellow. They're
Mm,
usually just green. Um, if anything, I could show you something else. Here's an
mhm,
example, but this is going to be a bit different. Just 1 second, resume.
mhm.
So if you look here,
Yes, there are many
this
different colors. Yeah.
this is like a poster that we created for print, but
Mhm,
this isn't colorized. So you see still that there's a black and white image in the background, right?
mhm.
So like
Yeah,
here, these are the buonia, I guess I zoomed in on. So
yeah,
everything here is black and white, in this
yeah.
case. But this is our dwell mode, and what the dwell mode does is it actually highlights each angle of the satellite's flight with a different color. So everything that bounces off the radar pulse, from a certain angle is colored blue. These are obviously all facing in this direction, so they were colored green. Anything that was, facing from when the satellite was facing left
Oh,
is
okay.
colored red. And then that helps you
Mm.
also as an analyst decide, which structures are facing which way. More importantly, it actually the color aspect gets applied by the satellite itself to man-made structures. So trees, anything that's very irregular will not be applied. Anything that's regular, like the ground, the roofs, anything that's super shiny, that will be super reflective. Those items will be added by color. But as you see, the main image is still black and white. The colors are just overlaid over the actual feature.
Okay. Perfect. Okay, so maybe other people also questions because I was talking.
Oh, sure. Edgar, are you here?
It sounds very Spanish.
Possibly not. Hello, Yvette.
Okay, also, I think they prefer to listen
Yes.
than to say. Okay, so but yeah, like we have talked for like 40, 45 minutes more or less around. So I guess Kacper, thank you very much
Thank
for your
you.
time. Thank you for all the details. And yeah, it was our second talk, so we'd like to express like our gratitude for this for time, the first time, the this now, and hopefully we'll work in the future in some
Sure,
different
absolutely.
projects.
And if you need to reach out in any way, these are credentials. Please don't write to Vitold. He will not reply. Feel free to write to me, and I will always do my best to respond, also on LinkedIn. So thank you very
Perfect.
much.
Thank you. Have a good day. Have a good week.
You
And
as well.
bye bye.
See you on the next one. Bye bye.